Yesterday you guys had trigonometry we were finding the sides of a different triangle, okay, using SOHCAHTOA that we did Wednesday. Yesterday we were finding sides. So what else is left of a triangle that we can look for today? An angle measurement, absolutely. So at the top of your paper, utilizing a right triangle, what should we write? For what method do we use finding the sides and find the angles? Say that again. SOHCAHTOA. And remember our little Indian princess that we had, and we named her SOHCAHTOA, and she was soaking her toe, hence the terminology SOHCAHTOA. Okay, so here we are, SOHCAHTOA. Yesterday we utilized SOHCAHTOA to find sides of a right triangle. Today we're going to be looking for an angle. We're going to be looking for the angle. This angle today on our notes are going to be represented with theta. Theta is a Greek symbol. We use a lot of Greek symbols in mathematics. Pi being one of the most familiar. But this is called theta, and we use that most often to represent an angle. I say that, but then again, you're going to get your homework, and X and Y are going to be used for your angle measurement. So understand that theta is most generally recognized as an angle, but not exclusive to that. You can still use variables as well. All right? So here we see our right triangle. We represent that with a little box that we put in the corner. And what side is across from our right angle? That is our hypotenuse. It's directly across from our right angle. So the side 13 is our hypotenuse. And then with the hypotenuse, what is the other side that makes up that angle? Adjacent. Adjacent means it touches. It's adjacent. And so adjacent and hypotenuse make up the angle in which I'm looking. Okay? So this is my unknown. That's what I'm looking for. And what, according to SOHCAHTOA, sine, cosine, tangent relates adjacent and hypotenuse? Cosine. Okay, so just for your note purposes, you're going to write cosine of theta. Always, after every trig function, needs to be an angle measurement because that's what it is. It's cosine, sine, or tangent of some angle. Okay, so cosine of theta is adjacent over hypotenuse. We see that, so we write it adjacent over hypotenuse, filling in the numbers appropriately. So 5/13. Okay, now, yesterday we did not know either 5 or we did not know 13, and we solved using our algebra. Here, we're looking for this angle measurement. So it's not so much algebra that we're using, but the keys on our calculator. There is a function on your calculator. So everybody look at your calculator. And right above cosine, you should see cosine with a little -1 in the exponent. Everybody see that on your calculator? That is called the inverse cosine. And we're going to be using that to find an angle measurement. That's the button that we use for angle measurement. So our next step in our notes, we would write it as cosine, which is the inverse of 5/13 is going to give us some angle measurement. So the inverse cosine of 5/13 is going to give us some angle measurement. So on your calculator, literally, you're going to type it in exactly as we have it written, taking the inverse cosine, 5/13, and you hit enter, and you should get 67.38. And prior to us starting, we should have verified that we're in what type of mode on our calculator. We need to be in degree mode. And so if you're not getting that number, you either picked the wrong inverse to use or you're in radian mode. So make sure that your calculator is set appropriately for that. So theta is 67.38 degrees. That is it. Okay? So this theta right here is 67.38. Okay? Let's look at number 2. Unless you guys, any questions on number 1? Okay. Number 2, I recognize my right angle. I go directly across from that and label my hypotenuse. Always a good place to start. Label my hypotenuse. From my hypotenuse, I can find the angle measurement that I'm trying to look for. Okay? So this is my theta. That's the angle that I'm looking for. Directly across from theta, side 12 is labeled as what? Opposite, because it is opposite the angle. Adjacent is not given, so I'm not going to worry about it. I have everything that I need in order to solve this problem. I'm looking for theta, given the opposite side and the hypotenuse. So what trig function, sine, cosine, or tangent, relates opposite and hypotenuse sides? Sine. So I have sine of theta is opposite over hypotenuse. Now, you see how we have 4/13? No, that's wrong. 4 times the square root of 13. If more than one operation is being taken place on the denominator, what do I need to put in the denominator? Parentheses. I need to put parentheses. So I'm going to take the inverse sine of 12 divided by parenthesis 4 times the square root of 13 is going to give me theta. This is a big parenthesis out here. But 4 times the square root of 13 is in its own set of parentheses. Okay, that looks really crappy, but I think you guys can figure out what we're doing here. So we type in inverse sine 4 divided by parenthesis. That would be 12 divided by another set of parentheses, 4 times the square root of 12. And then close out with double parentheses, and you should get 60. And that's how it should look. Inverse sine of 12 divided by 4 times the square root of, not 12, what is wrong with me? It's 13. It should be inside there. If you're thinking, wait a minute, how come I didn't get 60? It's because your teacher typed in the wrong problem. So it should be 56.31. Okay? 56.31. You're taking the inverse sine, and then there should be an automatic parenthesis that's given, right? 12 divided by parenthesis, then 4 times the square root of 13, and then 2 parentheses closing that. Got it? And you should get 56.31. And again, we're just making a common statement of rounding it to the hundredths. And since we are finding an angle measurement, that is represented as degrees. Okay? Questions?
Is that it? Does it get harder? No.
Okay, let's flip to the back side. Let's look at number 4. Now we're looking for 2 different angles. Okay, we're looking for A and we're looking for B. Given all 3 sides. So we have lots of choices that we can make. Do we want to start with angle A or do we want to start with angle B? We want to start with angle A because it comes first. Here's my right angle. Opposite of that, or across from that I should say, is my hypotenuse. And if I want to find angle A first, 3 becomes my adjacent side and 4 is my opposite side. So since all 3 of these sides are given, you can pick your very favorite sine, cosine, or tangent in order to solve this. There's not one that will be better or easier to use than the other. So I'm going to choose sine because it comes first in SOHCAHTOA. You can choose cosine or you can choose tangent. Let's see if we get the same thing. So I'm going to say the sine of theta is opposite over hypotenuse. I'm looking for theta, I'm looking for the angle, so I'm going to be using inverse sine of 4/5 equals, I go to my calculator, find the inverse sine of 4 divided by 5, you should get 53.13 degrees. Okay, so that is angle A. So angle A is 53.13. You guys get that?
Yeah.
Okay. Now we want to find angle B. And just so that we're kind of fair, I'll probably choose a different function rather than sine. So I might just go with cosine. If I do looking at angle B now, 4 becomes adjacent and 3 becomes opposite because I'm looking at it in terms of angle B rather than angle A now. So 4 is my adjacent side, B is my opposite side, 5 stays as hypotenuse no matter what angle you're looking at. So adjacent over hypotenuse is still 4/5, but using a different trig function, you should get a different answer. So inverse cosine of 4/5 is,
36.87.
that's exactly right, Harley, 36.87 degrees. Parker.
Couldn't we just do it like take the 53 plus 90 and then minus 180?
Oh, gracious, you would have thought that I just planted in there for that question. State that really loud again.
Couldn't you just add the 53 plus 90 and then minus 180?
Okay, all three of these angles need to add up to be what?
180.
180. If I know what's the degree measurement of a right angle?
90.
What do we find this to be?
53.
53. So did I have to use trig to come up with this third angle? No. And so what Parker asked is, seriously, do we really have to go through all this? Okay, he didn't say it quite so whining like that. Can't we just subtract 180 from all of that? The answer to that is absolutely. But here's my caution. Exactly. What if this was wrong? Then the whole thing is wrong. So to answer your question is yes, you may do that. But you're kind of rolling the dice on making sure that you know that this is correct. So 53, let's just do this for fun. 53.13 plus 36.87 plus 90. Well, hot diggity dog, I got myself 180 degrees there, okay? So you need to make sure, though, if you want to just do the subtracting part, that your first angle is accurate, okay? All right, let's look at this bottom one, number 6. Yesterday we had a word problem. The picture was given. This one, it's not. But since we are using SOHCAHTOA, what kind of triangle am I always going to have? Right triangle, and it has to be, otherwise I can't use SOHCAHTOA. So the base of a 24-foot ladder is placed 8 feet from the building. Feet. What angle does the ladder make with the level ground? Okay, so here's my right triangle with a little extended. There's my 90 degrees. Now, stay with me here on this. In a perfect world, a builder is going to make a building perfectly perpendicular to the ground, which would create a 90-degree angle. A ladder better not be placed completely perpendicular, or it would be very difficult. A freestanding ladder, not one that's built in. A freestanding ladder better not be, otherwise it'll fall, like in the cartoons, it'd fall straight over. So looking at this picture, is the left side my ladder, or is the right side my ladder?
Right.
The right. So this is my ladder. And how tall is my ladder? 24 feet. So the left side is my building. And if the ladder is placed, here's the base of the ladder. If it's placed 8 feet from the building, that means it's on the ground. That's the distance measured on the ground. So I want to know, what angle does the ladder make with the level ground? So it would be this angle right there that I'm looking for, because that's what's level with the ground. So if this is the angle, what side is the ladder? Hypotenuse, adjacent, or opposite? It is my hypotenuse. So therefore 8 feet is which side? Which trig function defines adjacent and hypotenuse? Cosine. So cosine of theta is my ratio of 8/24. To find the angle, I always use the inverse. So I take on my calculator the inverse cosine of 8/24.
70.53.
You should get 70.53 feet. Degrees. Finding an angle. Questions on that?